My name is Tyler Coleman. I'm the lead terrestrial wildlife biologist for Sequoia and Kings Canyon National Parks. I've been working in this position for about a year and a half, but I've been with the Park Service since about 2003. Our primary responsibility involves bear management. That includes mostly keeping bears and people separated and acting responsibly, keeping bears away from acquiring human foods when people come to visit, or even employees that might live here. The bear management team includes about 4 people. Occasionally we have additional volunteers, interns, and employees if we have additional funds. We have a bear management technician lead who's on staff for about 8 to 9 months per year. I oversee the program and involved with less day-to-day operations and more large goals, program direction, and I intervene or assist when a major issue arises. So there are a number of ways to find bears in the parks. There is pretty much anywhere you can identify a bear. There are certain times of the year they're more or less common at very, very high elevations. It's usually not too common to see a bear, although it does occur. Sometimes bears that are staying and frequenting areas above tree line, or bears that have maybe received a food reward from a wilderness hiker or wilderness user. But from the tree line down to the foothills, literally anywhere a bear can be at any point in time. Throughout the summer, we consistently see bears in the montane areas. A good example is the giant forest and lodgepole and areas around the giant forest and lodgepole. Bears throughout the summer forage on green vegetation, grasses, sedges, and forbs. So a great place to see bears are places like meadows or open areas, or even places near water, such as a stream corridor that might have green vegetation. A common food throughout the year is animal matter through insects, such as ants. Bears acquire ants through ripping up decaying logs, for example. So you'll often see on the forest a log that's been lying down and bear scratching on the logs. As the bears try to acquire those insects. You might also see a bear that's trying to acquire larvae of bees or wasps, doing the same kind of thing, digging into a log or even sometimes digging into the ground. In addition, bears have a very interesting reproductive cycle. It's similar but different than a lot of mammals. They use their process of annual hibernation to assist them with their reproductive activity. Bears often mate in the early summer, late spring, times like May and June. At that point, if they become impregnated, they do not have a developing fetus. The fetus essentially stops developing or slows to a great degree. It's a process called delayed implantation. Throughout the summer, then, after they've mated, they basically aren't using their energy stores to develop a young in their body. They're using their energy to accumulate fat. Once they enter into hibernation in late fall and early winter, the females begin the process of that embryo developing and continue to develop. At that point, they've been able to accumulate fat, and now they might have a cub or 2 or 3 in the den. So the gestation, as the fetus develops, is actually quite short, just a few weeks. And the cubs are born in the den during hibernation, often in late January or early February. At that point, the cubs are very, very small, like the size of a squirrel, about a pound, often blind and somewhat hairless, mostly helpless. But they begin to suckle and wean from the female as she's hibernating, and they begin to get bigger and bigger until the next spring, when they emerge from the den, usually a 5 to 10 pound small cub, but a cub that can actually be mobile and has fur and can see and walk. Now, the cubs stay with their mother for black bears for about a year and a half. After a cub is born and emerges from the den with mother, they spend that first year with the mother, and during that time they're learning how to forage, where to forage, how to find food, how to defend themselves, and learning everything about their environment. And then that next fall, they go hibernate with mother again. So you might have a female with 2 or 3 cubs in the den at the same time. That year, a female usually will not mate with another male. So they spend the winter with their cubs and they reemerge the next year, and the cubs are bigger. And at that point, we refer to them as yearlings. And then they spend a few months, maybe 2 or 3 at the most, with mom until early summer, late spring, when mom usually lets them go, or a more grisly encounter might involve a male that chases the cubs off and tries to get the female to come into heat, basically, a process called estrus. Sometimes the males will chase off the cubs to get the female to stop lactating. Once the female stops lactating, that will basically trigger her body to start estrus or come into heat. And she might breed with the male again, and the process will continue. So there are a number of reasons why we want to track bears. Primarily, we want the ability to know where they are if we need to find them. For example, if we have a problem bear in a campground, we can associate it with an individual, or we want to find bears so that we can learn more about them, where they're eating, where they're denning, how many cubs they have, so on and so forth. The most common tracking device is a radio collar. A radio collar is basically like a large collar you might see on a dog, but with a small battery pack and a tiny radio antenna. These are commonly attached to bears. They're relatively harmless if attached correctly. The radio collars essentially send out a signal to a radio device. If they're what's called if they're a VHF collar, if we purchase something called a GPS collar, they work in a number of ways. They can either collect an individual location and store it on the actual collar, or send the signal to an external device, either a satellite or another receiving device that's handheld. At that point, we have the ability to locate the bear anywhere in the landscape as long as we have a radio tracking device. We use antennas mounted on our vehicles and handheld antennas, even sometimes antennas mounted on planes to track individual bears. We can then find the bears, get closer, and observe them doing whatever it is they're doing at the time, eating, reproducing, nursing, or in some circumstances getting in trouble with people. This also allows us to intervene in situations. For example, if we have a bear that's become food conditioned and consistently comes into campgrounds, with the radio tracking device, we can be there before the bear enters the campground and help frighten the bear away before it receives a food reward or causes another problem. So there are certain circumstances when we are not able to apply a radio collar and track a bear, or we're able to apply a radio collar yet still have the need to acquire more information. So as bear biologists, we use a number of non-invasive techniques to learn more about bears, or even at times track bears or identify individuals. And there's a few that are commonly used. One is called the stable isotope analysis. An isotope is essentially a variant of an element. An element that has the same chemical properties but has a different atomic mass. A very common one is carbon or nitrogen. An element that's very common in the atmosphere. And what's interesting about that method is we can learn a lot about a bear's diet over a long period of time if we acquire a sample from that bear, non-invasively. So that can just be a hair sample, it can be a tissue sample, or it can be a carcass, for example, if a bear were to perish. Very commonly, hair is used to evaluate isotopes for a bear. What we can learn from that is through a hair sample processed in a lab, we can evaluate how many or what percent of different types of a weight of an element or an atomic mass of an element is in a sample. For example, carbon-13 is commonly found in sugarcane and corn crops. Now, those are not items that are available naturally for bears and Sequoia kings. However, those are foods that are very commonly eaten by people, corn and sugar. We can identify just how much bear, or roughly approximate how much human foods a bear is eating by evaluating how much carbon-13 is in a hair sample relative to another bear that's only eating natural foods. So without ever catching a bear or seeing it do something it shouldn't be, like acquiring human foods, we can learn about how much in its in its past how much human food it's been consuming. It's a very powerful management tool because we can look at a large number of bears at the same time and determine if our management actions are effective on a large scale at reducing the amount of human foods available to bears. Another commonly used method is DNA analysis in bear management. This is another non-invasive technique. It's being commonly used to learn more about bears without actually capturing bears and putting on a radio collar. Just like with stable isotope analysis, DNA can be extracted through most commonly hair, but also other methods such as a tissue sample, a bear carcass, or even dropping from an animal. Once a DNA sample is extracted, we can then do a number of things to learn more about that bear and apply those to different management actions. For example, we can get an individual fingerprint on a bear, so a DNA fingerprint, essentially learn which bear was at what location at what time. If we acquire a hair sample in one campground, we might learn later on, a year later, that a bear was in another campground through analyzing that DNA sample. But we can also evaluate things on a population level. We can try to estimate population sizes by getting a large number of DNA samples. We can also determine the overall genetic structure of a population. So, for example, how much inbreeding or migration do we have? And we can also learn how related two bears are, like a parent and sibling or parent or sibling relationship. All these things can help us manage bears on kind of a large scale without actually catching them, handling them, and putting on a radio collar. Another commonly used technique for evaluating the physiology of a bear is something called fecal cortisol analysis or stress hormone analysis. This is a new and relatively interesting technique that's being used to determine how a bear, learn more about how a bear might interact with its environment. Essentially what we do is when a bear makes a dropping, we can take that sample, process it in a lab, and determine how much stress hormone is in that sample. If we can correlate that to an individual bear, we can learn more about if that bear is undergoing stressful events and relate those to the environment. A good example would be a bear that's foraging consistently on the side of the road, or a bear that's interacting with people. What's important about that is stress hormones are something that every animal produces. It's considered a good thing. For example, it helps you with a fight or a flight response. The problem becomes with stress hormones when we have a persistent elevated level of stress in our bodies. For people, that's commonly measured through post-traumatic stress disorder. But this comparable type of thing can occur in different wildlife populations. If an animal is known to have persistent high levels of stress in the body, it can lead to lower reproductive rates and higher mortality rates. So if we learn more about the amount of stress hormones within an individual bear, we can come up with management techniques to help mitigate the impacts from those individual environmental stimuli. We are incredibly grateful for all the supporters of Sequoia Park's Conservancy. Without their support, none of this work would be possible, or much of this work would not be possible. And we hope very much going forward to continue some of this great work with your help.